remarkably complete skull belonging to an early human ancestor that lived 3.8 million years ago has been discovered in Ethiopia. This is the first time a skull belonging to Australopithecus enamusnus has been found, and the discovery sheds light on the evolutionary history of early human ancestors. Researchers have been working on the Ranso-Milpallion College research project study in the Afar regional state of Ethiopia for 15 years. On February 16, 2016, the upper jaw was discovered. They searched the area for more pieces over 16 hours and recovered the rest of the skull. A detailed analysis of the skull and where it was found was published Wednesday in the journal Nature. "I couldn't believe my eyes when I spotted the rest of the cranium," said Johannes Haile Selassie, study author and curator of physical anthropology at the Cleveland Museum of Natural History. "It was a eureka moment and a dream come true. This is one of the most significant specimens we've found so far from the site." The skull, referred to as Med, represents the early human ancestor known as Australopithecus enamusnus that lived between 3.9 and 4.2 million years ago. They are the ancestor of Australopithecus afarensis, to which the famed Lucy skeleton belonged, and is believed to have given rise to our genus. Homo afarensis came along later, living between 3 and 3.8 million years ago. The Med skull was found only 34 miles north of where the Lucy skeleton was recovered in 1974. An international team of geologists, paleontologists and paleoanthropologists helped to determine the age of the skull by studying the habitat where it was found. The enamusnus skull, which likely belonged to a male, was transported a short distance down a river after death and buried by sediment in a delta. According to Beverly Saylor, study author and professor of stratigraphy and sedimentology at Case Western Reserve University, it was likely living along the river, which was surrounded by trees. The larger area away from the river was open shrubland. Med lived near a large lake in a region that was dry. We're going to conduct more work in these deposits to understand the environment of the Med specimen, the relationship to climate change and how it affected human evolution, if at all, said Naomi Levin, a co-author on the study from the University of Michigan. Previously, researchers believed enamusnus, which was only previously known from isolated bone fragments, died off and gave rise to afarensis. But the skull discovery reveals that the two species likely overlapped and coexisted for at least 100,000 years. This challenges the idea that human ancestors evolved in a linear fashion. The researchers found themselves looking at a face they had never seen before. The features of the skull were catalogued so it could be compared with all other known hominin species from eastern and southern Africa. Certain aspects of the skull also revealed how it might be related to other species. Australopithecus on the whole were known for their massive faces. According to Stephanie Melillo, study co-author and postdoctoral researcher at the Max Planck Institute for Evolutionary Anthropology. But the evolution toward a more human face began with the origin of our genus, Homo. That's when early humans were using tools and eating food that had been more processed. As the oldest known member of the Australopithecus genus, enamusnus possesses a mix of intriguing features. It has a protruding face and the cheekbones project forward. Australopithecus on the whole were known for their massive faces. According to Stephanie Melillo, study co-author and postdoctoral researcher at the Max Planck Institute for Evolutionary Anthropology. But the evolution toward a more human face began with the origin of our genus, Homo. That's when early humans were using tools and eating food that had been more processed. As the oldest known member of the Australopithecus genus, enamusnus possesses a mix of intriguing features. It has a protruding face and the cheekbones project forward. It's the very beginning of the massive face, built for processing really tough diets and chewing hard food, Melillo said. The bones of the face were built to withstand strain. The canine teeth found in the skull were very large, but they're still comparatively small next to the canines of afarensis. The long, narrow brain shakes is small, like other early human ancestors, and researchers are still trying to understand what caused brain capacity to increase when the genus Homo arrived on the scene. Haile Selassie's theory is that Homo used more tools, consumed more meat and moved around in its open habitat, prompting them to make more decisions.